are the questions from FA2, Unit 6 FA2. So even though the first one says to use the square root method, okay, I'm going to show you how to solve this by hand, review that method with you. What I was just saying is that a lot of times you can use a different method than what it's suggesting or saying to use. Okay, so you can use your judgment on what method you want to use. So the square root method requires you to isolate the term that is being squared. So in this case, oh, that was supposed to be a highlighter. Try that again. That is this. X minus 3 is what's being squared. So I need to get that by itself. Okay, so I'm going to move the 16 to the other side by adding it, because that's the opposite operation, and what we do to one side, we do to the other. So I end up with 16 equals x minus 3 squared. Once you isolate what is being squared, you're ready to take the square root. What you do to one side, you do to the other. Okay, the whole point is that the square root cancels the square out, and you're left with just the term that was being squared, x minus 3 in this case. Okay, now over here, if I take the square root, don't forget your plus and minus. When you're taking the square root as the operation, when you're solving an equation, you have to put plus or minus in front. So what is the square root of 16? So I get plus or minus 4 here. Technically, I can just drop these parentheses. I don't need those because all that's left over there is x minus 3. So I've got positive or negative 4 is equal, what the heck, come on, stylus, is equal to x minus 3. The whole point is to solve for x, so I still need to move that minus 3 over, so I'm going to add it. What you do to one side, you do to the other. Remember, you're taking the positive 4 and adding 3 and the negative 4 and adding 3. So 4 plus 3 is 7, and negative 4 plus 3 is negative 1. So that one had 2 solutions. And again, I'm going to pull up what that looks like in Desmos. If you chose to solve by graphing, if I plugged that equation in, x minus 3 squared minus 16, I can go over here and actually click and see, yeah, my x-intercepts are at negative 1 and 7. So I could have done this by graphing as well. Okay, I know it doesn't ask this, but just to reiterate, look at the other answer choices. So this one had 2 solutions, 2 real solutions. It crossed the x-axis twice. If it only had 1 solution, what would that mean graphically for that parabola? If there's only 1 solution, what does that mean about your parabola? What is the solution? The solution is what's the other vocab term for it? X-intercept. So if this is saying there's 2 solutions, that means there's 2 x-intercepts. So if there was only 1 solution, that means there's only 1 x-intercept, right? That would mean that the vertex, the turning point on the parabola, would actually be on the x-axis, wouldn't it? If there was only 1 real solution. Now, what about answer choice B? What type of number is this? What is that after the 4? Y'all, do you know you have a test this week? Might want to participate, answer some questions, make sure you know what you're doing. Okay, that's an I. What does that mean? I is the equivalent of the square root of negative 1. Yes. but that's not what I'm asking, because this is simplified. This is as much simplified as I can get. But what type of number is this because of that I? Imaginary. If you see an I, you have an imaginary number. This is a complex number. Remember A plus BI form? So this complex number, okay, it's imaginary. Graphically, if you had an imaginary solution, what would the graph look like? What does that mean in terms of your x-intercepts? We just said if there were two real solutions, it's two x-intercepts. If there was one real solution, that means there would only be one x-intercept. What if there's no real solution, only imaginary? What does that mean about your graph? That there's no x-intercept. Very good. Okay, so just knowing that will help you eliminate some answer choices for some problems. Okay, so if you, because there's one later here, I'll go ahead and I'm going to do this out of order just to show you what I'm talking about. Number 3, for instance, it says, what are the solutions to this equation? So if I were to look at this graph, x squared minus 10x plus 61. I don't even see it right now. Let me keep zooming out. Oh, there it is up there. Are there any x-intercepts for this parabola? Does it cross this x-axis ever? So what answer choices here can I immediately eliminate, just knowing that there are no real solutions? I can eliminate A and B. Okay, A and B are both real solutions. B looks a little more complicated because you see those square roots, but those are still real numbers. There's no I there, is there? Those would just be irrational numbers. Those would be decimals. When I go and click on them on the graph, I click on the x-intercept, it would show me the decimal value for that. But that's not the case here. It's a decimal, it's not an integer. It's not a real solution. It's imaginary. So I know it's got to be one of these that have I. Does that make sense? Okay, so make sure you understand if there's imaginary solutions, that means there's no x-intercepts on the graph when you look at it. All right, so we've narrowed it down. Even not knowing how to solve this, just knowing what imaginary numbers mean, you've doubled your chances of guessing correctly because you've narrowed it down to 2 answer choices instead of 4. Now, to find the solutions, I already know it's going to be imaginary, so I know factoring is not going to work. Graphing helped me narrow it down, but it didn't solve it. So didn't do graphing or factoring. I could do, it's not set up for square root method because you've got an x squared and an x. Square root method, you just want the x squared term. Okay, there's no bx term. That's when you can use square root method. So I'm down to either completing the square or quadratic formula. Y'all have a preference on a method out of those two? Those are the two that will always work, no matter if they're real or imaginary solutions. You do not have to, I know I sang to you the Pop Goes the Weasel version of the quadratic formula to help you remember it. You don't have to have it memorized. Okay, you will have the quadratic formula on your scratch paper for the test. So knowing that, do you have a preference on completing the square or quadratic formula? No? Do y'all remember the completing the square method? Can anybody tell me what to do to complete the square? If not, quadratic formula should be your option because I'm going to give you the quadratic formula. Okay, I'm not going to list out the steps for completing the square. You have to know them to be able to use that method. Okay, so I guess I'll do this one by quadratic formula. Because remember, quadratic formula, I'll sing it one last time for you. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You don't have to memorize it. It will be written out like that. Now you have to be able to identify what is A, B, and C. So your equation has to be in standard form to be able to identify A, B, C. What is A here? B and C. Good. So now I'm ready to plug those in. I talked about last week when we did these notes, I would always, always, always use parentheses when I'm substituting numbers in. So I got my B's plugged in. A and C. And A again. So now I'm ready to simplify. So in the denominator, that's just a 2. Here, that's going to become a positive 10. Now I just need to simplify what's under that radical. So what is negative 10 squared? 100 minus, and then that's gonna stay a minus because I can see it's a negative times a positive times a positive, so I know it's still gonna be negative. Okay, so I just need to do 4 times 61 is 244. So what is 100 minus 244? Negative 144. What did we just get through talking about? With a negative under the square root, what does that mean? It's imaginary. I'm going to pull that negative out. It's going to become an I. What about the square root of 144? That's a perfect square. What is it? 12. So instead of the square root of negative 144, that's going to become 12i. Now remember in our notes last week, I talked about you can reduce with this denominator only if both pieces are able to reduce. So it's like it makes a little triangle there. So the 10 over 2 will reduce to 5. And the 12 over 2 is 6. So we did that by quadratic formula. You could have used completing the square if that was how you chose to solve it. You should have gotten the same answer. So far, so good? All right, so I skipped number 2, so let's go back to that one. So this is a multi-part question. Again, there is more than one way to solve these. All of these answer choices match the equation with the solution set. So these are the solution sets on the top. These are the equations. So we have to pick what are the solutions to this one. So it's like a multiple choice, it's like 3 multiple choice questions. The first one is set up to use what method pretty easily? Is there an x term or just the x squared term? Just the x squared. When that's the case, when there's not the x to the 1 power term, you just do the square root method. Okay, just solve for x. Now, to solve for x, before I can take the square root, I need to get rid of that 4, right? You got to isolate what's being squared. So this is going back to what we did in number 1. We got to isolate what is being squared. So I got to get rid of that 4 first. So divide out 4. And this comes out to x squared is 49. Now I've isolated what was being squared, so I'm ready to take the square root. Don't forget the plus or minus. Square root of 49 is 7. So positive or negative 7, do you see that as an answer choice? Yep, right there. Okay, what about this second one? Would I be able to use square root method on that one? Yeah, there's no x term, right? There's only the x squared term. So I need to isolate it. Get that by itself. What do I move first? The -3 or the +8? I'm trying to isolate that x squared. Yeah, the 8 needs to move first. So I end up with -3x squared equals -8. And then how do I get rid of that -3? Divide. -3 is being multiplied by x squared, so the opposite is to divide. So negative divided by negative, that's a positive. So still just positive 8/3. Now we're ready to take the square root of both sides. Don't forget your plus or minus. So positive or negative square root of 8/3. See that as an option? There it is. All right. I'm going to circle this one since I circled that one. All right, last but not least, looking at the third equation down here. Is this one that we can use the square root method on? Is it the same format as these two where there's an x squared term but not an x term? There's an x term this time. We cannot just use the square root method this time. Okay, so I have to choose a different method. I could choose factoring. I could use completing the square, or I could use quadratic formula. Or I could use graphing. I could try graphing. Now, I could have done graphing with all of these, but the thing is, and I can see all of my answer choices are real. None of those have an I, right? The issue with graphing is all of these would be decimals, except for the 7, obviously, plus or minus 7. But all these others would be decimals. So I would have to plug each of these in and see what decimal it comes out to see if it matches, which one matches the decimals that show in as the x-intercepts. Now, I'm not saying that you can't do it that way. You can. You just have to get all of these as decimals first. Does that make sense? Okay, so graphing is an option on this one, but I'm going to review one more time the quadratic formula. So the quadratic formula says to identify A, B, and C. So A is 4, B is -1, and C is -6. Again, remember this is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and then we need to reduce, simplify a little bit. Okay, so my denominator is just 8. Okay, that's going to become a +1. Plus or minus, and we just need to simplify what's under that radical. So -1 squared is just a 1. And then I can see this is negative, positive, negative. So negative times a negative, that's going to be a plus. And then 4 times 4 is 16. 16 times 6 is going to be 96. So 1 plus 96, that's 97. Do you see that as an answer choice? 1 plus or minus root 97 all over 8. There it is. Make sense? All right. One last one from this FA. Number 4 was another multi-part question. So it asks, or it says, excuse me, the characteristics of the quadratic function, and then it gives us the function x squared minus 8x minus 20, are illustrated by first completing the square. Okay. And then there's a table that shows 4 statements. They want us to answer true or false. Now, I know it says completing by first completing the square. Okay, so I'm going to review the completing the square process, but that I'm going to show you, you could answer all of these by graphing it too. Okay. But to review the completing the square process, remember, we want the equation set equal to 0, which we've already got it in that format. Take out the GCF, the A, if there is one. There, A is an understood one, no GCF to pull out. Okay, so then the next step is to move the constant to the other side. So this minus 20 gets added to the other side. So this ends up being x squared minus 8x equals 20. Once you do that movement. Okay. Then the following step is to identify your b and do b divided by 2 squared to figure out what you need to add to both sides. Okay, so b divided by 2 squared. My b is the negative 8. So that's negative 4 squared is 16. So 16 gets added to both sides. Okay, now I create from this perfect square trinomial, I create a binomial squared. Okay, remember the sign? It's going to stay as is, and it's half of b. So that's the 4. So x minus 4 squared equals, and then over here, that ends up being 36. Okay, so there's my equation in a different format. Okay, almost vertex form, if you will. I would just need to move the 36 back over to the other side and have it set equal to 0 to be proper vertex form. But that mimics this format over here, doesn't it? That it asks if it's the equivalent of. Are those the same? X minus 4 squared equals 4. Is that what we got when we did completing the square? X minus 4 squared equals, we got 36. So that's false. Okay. Now, these others are harder to answer just based on the completing the square. We could take the square root of both sides and finish solving for x to see what the roots are. And you would see that this is true. This comes out having those roots. If I take the square root of both sides, don't forget my plus or minus. And then I would have to add the 4 over. I end up doing 6 plus 4 and negative 6 plus 4. So the 6 plus 4 is 10 and the negative 6 plus 4 is negative 2. So those are the correct roots or x-intercepts. Okay. Now, the axis of symmetry is going to be halfway between those roots. So is 4 halfway between 10 and negative 2? Okay, those are a distance of 12 apart, so it's 6 in each direction. So I can do 10 minus 6 or -2 plus 6. Either way, yes, that gets me to an axis of symmetry at 4. Okay, now is the lowest point on the graph 4, 4? One way to answer this is to plug in that x value of 4 into the equation. And you could do that up here where it's equal to f of x and figure out what that should be. Okay, but most of you, I think graphing would be the easiest method here. Okay, y'all have a good day. I'm going to finish this recording. Okay, so if I looked at this one graphically, it's x squared minus x minus 20. I can see there's the x-intercept, so I could have gotten that that's true by looking at the graph. I can see that my axis of symmetry is where x equals 4. We can see that's the x value at the vertex. So I can see that that's true based on the graph. Now, that lowest point being at 4, 4, I can immediately see no, the lowest point's at 4, -36. Okay, so that was false. Now, if you were trying to do all of this by graphing and you weren't sure about this first one, if you want to know if something is equivalent, type it in and see if it's the same graph. X minus 4 squared. Now, here's where it's tricky. We don't want it equal to 4. We want it equal to 0. So I'd have to subtract that 4 over. So it'd become -4. So now I can see that would be the graph for this equation. Okay, and again, I wrote it by subtracting that 4 to the other side, so it was set equal to 0 so that I could graph it properly. And we can see those are not the same graph, so those are not equivalent. Okay, so you can do it by completing the square by hand, or I could have answered all of these by looking at the graph as well. Okay, so take advantage of the fact that you get the graphing calculator for the whole test. Now, there was some that didn't get us an answer because there was no real root, no real solution. There was only imaginary. Okay, and so we had to be able to get those figure out the imaginary answer on that one. We had to be able to do quadratic formula. So if I am going to give you a tip on how to study, what to practice, what to focus on, we learned all 5 methods. But like I've said multiple times, you don't have to be able to do all the methods. I would make sure that you can put in the equations in the graphing calculator and understand what you're looking for to solve by graphing. And then you need to be able to use quadratic formula. Okay, those would be, I think, the top 2 to make sure you've mastered. Okay, and then you can go through and focus on the other ones. Okay, factoring is extremely important in the long run, but for this particular test, it's not, because it's not the only way to solve. Okay, but you still really need to know how to factor. It's going to become even more important next unit. All right. Just real quick, what I was saying earlier, I didn't show this to you, but I told you you could do this by checking these in the calculator. What I meant is, so like this last one is 4x squared minus x minus 6. There's what that graph looks like. But when I click, I get these decimals, these irrational numbers. And so looking at the answer choices, I don't know. But you could find out. You could plug in your answer choices. Okay, I could do, I need to make it a fraction. I'm going to go ahead and put divided by to get it as a fraction. And go back up there and put 1 plus, and then remember the square root is right here, of 97 over 8. 1.356. Hey, that's that one right there. And then I could change it from a plus to a minus. 1 minus Square root of 97 over 8, negative 1.106. There it is. So this written as a decimal, then I can check it in the calculator and see that it matches. So yes, I could have done this graphically as well. You just have to be able to type this in and see what it is as a decimal. You need to be able to type it in correctly. Make sure it's written as a fraction like this. You can't do the plus and minus together. You have to do plus and minus separately. Okay, you have to know where to get the square root. That's down here on the keyboard, right at the bottom here. I think that's the gist of it. All right.